Hi, Pre-Cal. Welcome to your Unit 1 test review. This video will be about half of the review, and then another video will have the other half of the review. So let's take a look at your test dates. Make note of those. And the question of the unit, how do you find the inverse of a function? Switch x and y. Okay, then if it's an equation, then we'll solve that equation for y so that it's in a nice form. Okay, then there are some types of equations that need restrictions to make the inverses functions as well, and those are quadratics. If you start out with a quadratic, to make its inverse a function, you can only use part of that parabola. And the part we use is from the vertex to the right. And what that does is with the inverse, that makes the inverse only the top piece, which means it is a function. So the restriction is always the vertex x coordinate to infinity, wherever that vertex is to infinity. It's only needed when we start with a quadratic. So let's take a look at finding some of these inverses. Let's look at number 3a. We're given f of x equals, remember f of x is just another way of saying y. So to find the inverse, we switch x and y. So y becomes x equal to the square root of, now that's a y, minus 4, and then a minus 1. We want to solve for y. First thing we need to do is move that 1 over to get the square root by itself. So x plus 1 will be the square root of y minus 4. And then to undo that square root sign, we need to square both sides. So we'll have x plus 1 in parentheses squared equal to y minus 4. And yes, we can leave this left side in this form. You do not have to expand that out. You could if you really wanted. Don't worry about it. Don't worry about expanding that out. To finish solving this for y, we need to add the 4. We can't add the 4 into the parentheses because it's already squared. So we just put a plus 4 out here. So in proper inverse notation, f inverse of x is equal to parentheses x plus 1 all squared plus 4. And there is your inverse function. Since this started out as a square root function, it does not need any restrictions. So if we look at B, we have a quadratic. Remember, f of x is y equals. So when we switch x and y, we get x equal to, open parentheses, now that's a y, minus 3 in parentheses, all squared, plus 1. We need to isolate the parentheses squared, so we'll subtract 1. X minus 1 will equal y minus 3, all in parentheses squared. And then to solve that, we need to take the square root of both sides. So we have the square root of x minus 1, and that really does need a plus or minus sign because we took the square root in order to solve. That's equal to y minus 3. Then to finish this, we need to add 3 to each side. So that gives us 3 plus or minus square root of x minus 1. So the inverse, f inverse of x, is 3 plus or minus the square root of x minus 1. This is your inverse. Now, Because this is a quadratic, it does need restrictions. Okay, this is a quadratic, so it needs restrictions. The original is quadratic, so it needs restrictions. Okay, the original quadratic needs restrictions. So if we take this original quadratic, y equals x minus 3 all squared plus 1, if we consider its vertex is 3, comma, positive 1. The 3 from here changes signs, the 1 from here. So that vertex being 3, 1, the restriction here is always from the vertex to the right to infinity. So that vertex x coordinate is at 3 to infinity. To make the inverse a function, the original domain has to be restricted to 3 to infinity. Let's take a look at C. Again, we start out with a quadratic, y equals, swap that to x, equaling, open parentheses, now that's a y, plus 1, close the parentheses, square, minus 4. We need to move the 4 over to isolate the squared term. So x plus 4 would equal y plus 1 in parentheses, all squared. Then we need to take the square root of both sides in order to solve. We took the square root to solve, so that's a plus or minus square root of x plus 4, equaling to the square and square root undo each other, so that's y plus 1. And then we need to subtract the 1. So negative 1 plus or minus square root of x plus 4. And that is our inverse. F inverse of x is negative 1 plus or minus square root of x plus 4. That x plus 4, all of it does stay under the radical. Okay. And again, we have a quadratic to begin with, so we will need to restrict. Okay. Our vertex here is negative 1, negative 4. Remember, yes, that x feels like an opposite sign. That y coordinate does not. So our restrictions here are from that x coordinate of the vertex, negative 1, to infinity. Now, let's check D. We start with y equals square root of 2x plus 4. Finding the inverse, switch x and y. X equals square root of 2y plus 4. To solve this, the entire right-hand side is under that radical. So to undo any of that, we would need to square both sides. So x squared is equal to 2y plus 4. We need to continue getting that y by itself. So we subtract the 4. X squared minus 4 is equal to 2y. And then we need to divide by 2. So we have a couple different ways we can write this. If we divide by 2, we get y equals x squared minus 4 over 2. And that is an appropriate way to write the inverse. X squared minus 4 all over 2. Now, another thing you can do, and another way you may see it if it were a multiple choice, is if both terms were divided by 2. I meant to do that here. If both terms are divided by 2. We'll leave that there. If we divide both terms by 2, we get x squared over 2 minus 4 divided by 2 is 2. Either one of these forms is correct. Either one of these forms is correct. It may divide each individual term by 2 and simplify, or it may not. All right, let's get away from inverses and let's look at domain and range of this step function. Hopefully this idea of step functions is getting a little familiar to you. In the domain, we start at -8, and that is a solid dot, so we use a bracket, okay? That piece stops at -5, but -5 gets used in the second step. So -5 is used somewhere. Then that second step ends with an open at -2, but that -2 gets used here. And we go from -2 all the way to 4, and that 4 is open on that step, but that 4 gets closed by the step above it. So we don't actually have a gap there. And this last step ends at 9. So from -8 to +9 is our domain. Each x that is used gets, each x that's open gets used by an x in a different step. So there are actually no gaps in this domain. Now, if we look at range, range is the y values, and the only y values that get used are those individual y values for each step. Okay, the individual y values for each step. So we list those with those curvy braces. Those y values would be -2, +1, +4, +7. We close those parentheses. Now, on what interval are these functions increasing or decreasing? And that is none. The function does not exist between the steps, so there is no increase or decrease. To be an increase or decrease, we would have to have some kind of slant, and none of the steps have that slant. And then the question's asking in part E, is the function continuous over its domain? And yes, it is, meaning once the domain starts, nothing interrupts it. Okay, there are no gaps or breaks in the domain from when it starts to when it ends. No gaps or breaks within the domain. So let's look at the next page and let's look at graphing this piecewise function. Do this slightly. This first equation, y equals x minus 1 all squared plus 6, that is a quadratic. Its vertex is at 1, 6. Here's the 1, here's the 6. So if we go to 1, 1, 2, 3, 4, 5, 6, here's our vertex. And then to graph that from there, we use the quadratic parent function. Go across 1, square it, we go up 1. Go across 2, square 2, we go up 4. And at this point, we're out of room. So we go left 1, we'd go up 1, left 2, 2 squared is 4, so we go up 4 from that vertex. Okay, now we are only using the values here that are greater than 3, greater than or equal to. Because that's I meant less than or equal to. That is less than or equal to. So we use a solid dot on x equaling 3. So when x equals 3, here's our solid dot on this parabola. And then x less than, we follow our graph to the left. So from this solid dot, I'm going towards the left, which happens to curve down and then curve up. So here is the piece of this function that we are using. Now, in the other function, y equals 4 minus x. It's a single power of x, a single power of y. That's a line. So y-intercept is 4. Its slope is -1. We can think of that as -1 over 1. So start at that y-intercept of 1, 2, 3, 4. And our slope is -1. So it makes that perfect diagonal, down 1, right 1, all the way down. Now, we're not using all of this. We are only using the parts of it that are where x's are greater than 3. So that's going to be an open circle where x is 3. So again, here is where x is 3. We have our dot right here. That needs to be an open dot. And it's greater, so we go to the right. And here is our piecewise function. So let's talk about the increase and decrease intervals here. The function is increasing. That means the y's are going up. Okay, the y's are going up. The only piece where this increases is right here. That's where, as we go left to right, the y's are going up. So that's from the vertex of the parabola, which is 1, to the end of that piece, which is 3. And on intervals of increase, decrease, we always use parentheses, not brackets. Always use parentheses on those intervals. Intervals of increase, decrease. Then it also asks where that function is decreasing. If we start here on the left, it does decrease right here. So that's from -infinity to 1. And then also this whole linear piece decreases, and that starts when x is 3 and goes to infinity. There are your intervals of decrease where the graph goes down. Here's where the graph goes up. So there is a piecewise function. All right, let's look at 6 through 9. We have our two functions, f of x and g of x, and we are going to find some values of those functions. On number 6, we're using the f function. So write the f function with nothing written in place of the x. Then take this x plus 1 and plug it in. Now, we need to simplify this. So take the x plus 1 and we need to square it. Remember, to square that x plus 1, we multiply x plus 1 by x plus 1, and we distribute, FOIL, do all the rainbows, however you think of that. Okay, so as we do this, let me scoot over. We have x squared plus a 1x plus another 1x plus a 1. And then we are distributing that -8 So we get negative 8x minus 8. Remember, that was a negative 8 we distributed, plus a 5. Now, as we combine like terms, x squared is the only x squared term. Then we need to add the x's. 1x plus 1x is 2x minus 8x gives us negative 6x. And then we need to add the constants. 1 minus 8 is negative 7 plus 5 is negative 2. And here is f of x plus 1. Let's take a look at number 7, g of negative 5. Write down the g function with nothing plugged in for x. Just write the whole function down. Then this negative 5 goes in place of all the x's. So working this out, negative 5 to the third power, negative 5 times negative 5 times negative 5. That's a positive 25 times a negative 5. So that's negative 125. Then negative 3 times negative 5 is a plus 15. And then minus 10. Negative 125 plus 15, that's negative 110. And then we subtract a 10, and that is negative 120. If it helps, you can do 15 minus 10 first. So you'd have negative 125 plus 5, giving us that negative 120. So on number 8, let's do f of 4. Write down the f function with nothing plugged in for x. Write down the whole function. Then take that 4 and put it in place of all the x's. Then work this out. 4 squared is 16 minus 32 plus 5. 16 minus 32 is a negative 16 plus a 5. So this equals negative 11. So I lost what color that was. It was that one. So f of 4 is negative 11. Let's take a look at 9. 9 wants the g function, so write down the g function with nothing plugged in for the x. Then we'll plug in e in place of the x, and there's really no work to do here. This is e to the third minus 3e minus 10. It basically just changes the variable. So there are your function notation type of problems. Let's take a look at number 10. We are writing an equation and finding the slope of the vertical line through the point 7, 1. We're thinking VUX, V-U-X, equals V for vertical, U for undefined slope, X for crossing the x-axis, and X equals for the equation. So our equation is x equals a number. It has to be the x coordinate. So x equals 7 is the equation of the line. That's it. X equals 7. X equals a number is the equation of a vertical line. It also asks for the slope. The slope of a vertical line, it's that u in VUX. It's undefined. Don't say it's 0. it is undefined. Now, for 11, we're finding the equation and the slope of a horizontal line through a point. So for horizontal line, we think HOI equals H for horizontal, O for slope is 0, Y for crossing the y-axis, Y equals a number is the equation. So the equation of a vertical line is Y equals a number. It has to be the y coordinate of the point we're going through. So our equation is y equals 6. It's only y equals 6. There's no x value, x term in a horizontal line. So the slope of this line is 0. Slope is 0. Now, let's take a look at number 12. And we are going to write the equation of the line through 2 points, x1, y1, x2, y2. First thing we need to do is find the slope of the line. Slope of the line be y2 minus y1 over x2 minus x1. So that is 2 minus 1 over 6 minus 4, which is 1 over 2. So our slope is 1/2. Now we need to plug in to find the equation. Formula we can use is y minus y1 equal to m times x minus x1. So plugging that in, y minus y1 is 1 equal to our slope is 1/2 times x minus our x2, our x1 is 4. Now, solving this, y minus 1 will equal 1/2 x minus 1/2 times 4 is simply 2. And then we need to add 1. And once we add 1, we get y equals 1/2 x minus 1. There is the equation of our line. These formulas and HOI equals, VUX equals will be given to you on the test. So let's check out number 13. We're writing the equation of a line that is perpendicular to this one and contains this point, x1, y1. So this original slope of the line, y equals 3x minus 5, that original slope is 3. It's the coefficient of x. So that perpendicular slope, and the one we'll need to use, changes the sign and flips the fraction. Flip the fraction, change the sign. Now we can plug into our point slope form here in order to write the equation. So we'll have y minus, our y1 is -2, so that's going to be a +2, equal to m is -1/3. Then x minus, our x1 is 9, close that parentheses. Then solve. Y plus 2 will equal -1/3 x plus 1/3 of 9 is 3. And then we need to subtract 2 on both sides. And y is -1/3 x plus 1. And here is the equation of the line. Let's take a look at 14, and this is a little bit about odd and even functions. A polynomial has an even or odd degree. Polynomial has an even or an odd degree based on the degree of its highest power. The degree is the highest power of x that's present in the polynomial. Okay, so if you have an even function, it has an even degree, and on an even function, the left and right ends point the same direction, as in both point up or both point down. Then on an odd function, the left and right ends point opposite directions, meaning one points up and one points down. All right, and that same information answers question B. Okay? If we're talking about positive and negative leading coefficients, okay, with a positive leading coefficient, the right end of the graph points up, meaning on the right side of the graph, the y values are increasing. On a negative leading coefficient, the right end points down. Meaning the graph is decreasing as we go to the right. All right, let's take a look at 15, and let's look at whether these are even or odd and have a positive or a negative leading coefficient. So I'm going to look for even and odd first. So on A, one end is up, one end is down. That makes it odd. On B, one end is up, the other end is up. That makes it even. On C, one end is up, the other end is down. That's opposite. That makes it odd. Okay. Then let's take a look at whether that has a positive or a negative leading coefficient. On A, that right side goes down, so it's negative. On B, the right side is going up. That makes it positive. On C, the right side is going down. That makes it negative. And we can disregard the function being even or odd. It goes with the degree. Okay. So let's look at D, E, and F. On D, we have a down and an up, so that's an odd. On E, we have a down and a down. That makes it even. F is up and up. That makes it even. And then with the coefficients, A, the right side goes up. That's positive. I meant D, the right side goes up. E, the right side goes down. That makes it negative. And on F, the right side goes up. That makes it positive. And that is even and odd coefficients. This is the end of this part of the review. Number 16 through the end will be on a separate video. Thanks for hanging in there with us, y'all. Good luck on your test. Bye.